5. 7 million years ago, the Mediterranean Sea was disappearing. Not slowly, not gracefully, but catastrophically. The way only the Earth can move when its tectonic machinery decides to do something enormous and irreversible. The Strait of Gibraltar, the narrow channel connecting the Atlantic Ocean to the Mediterranean basin, had been closing for thousands of years as the African and Eurasian tectonic plates ground into each other in geological slow motion. And then approximately 96 million years ago, the connection closed for the last time. The Atlantic stopped flowing in. The Mediterranean, sitting in a hot climate that evaporates far more water than rivers alone can replace, began to shrink. Its surface dropped, its edges retreated, its vast interior became first a chain of hypersaline lakes, then a salt flat, then a sunken desert basin sitting 3 to 5 kilometers below the surrounding land. Deeper than the Grand Canyon is wide, hotter than almost anywhere on Earth. A dead, salt-encrusted abyss where one of the world's great seas had been. Geologists call this the Messinian salinity crisis. It is one of the most dramatic geological events of the last 10 million years, and it is the backdrop against which the most controversial and potentially most important footprints in the history of human origins were pressed into the coastal mud of what would one day become the island of Crete. Because just before the Mediterranean finished dying, just before the sea retreated for the last time and the salt desert swallowed the basin, something walked along that retreating shoreline. It walked on two legs. It left its prints in the soft coastal sediment of the late Miocene shore. And those 50 footprints, buried under millions of years of geology and then exposed again by coastal erosion near a small village called Trekilos in western Crete, have been sitting in the open air waiting, first for a scientist on vacation to notice them, and then for the rest of the scientific world to figure out what exactly they mean. What they mean, if the researchers who have spent the last 2 decades analyzing them are correct, is that the entire foundational story of human origins needs to be rewritten, not refined, not adjusted at the edges, rewritten from the beginning. The footprints were first noticed in 2002 by Gerard Gierlinski, a paleontologist at the Polish Geological Institute, who was on holiday in western Crete when he walked across a rocky beach surface near the village of Trekilos and saw something pressed into the ancient stone beneath his feet. Gierlinski was a professional. He recognized fossil tracks when he saw them. He understood immediately that what he was looking at was unusual, but the full weight of the discovery, what these tracks actually were, how old they were, and what they implied for everything science thought it knew about human evolution, took another 15 years of careful, systematic scientific work to fully establish. In 2012, he returned with permission from the Greek government to conduct a proper study. The team that assembled around the site used laser scanning equipment and 3-dimensional imaging to document approximately 50 individual footprint impressions, spread across roughly 400 square meters of ancient coastal rock. They measured each print with morphometric precision. They built digital models. They compared those models against the feet of modern humans, chimpanzees, gorillas, bears, and every other candidate that could conceivably have made the tracks. And when those analyses came back, the team led by Gierlinski and including Per Ahlberg, a professor of evolutionary biology at Uppsala University in Sweden, sat with the results for a long time before they felt ready to tell the world what they said. What they said was this: the Trekilos footprints were made by an animal walking on 2 legs. Not occasionally, not experimentally, not in the awkward, wide-based shuffle of an ape temporarily testing its hind legs, but in fully committed, architecturally structured bipedalism, with the full body weight pressing down through an upright posture and the feet striking the ground in the alternating single-foot pattern of a genuine biped. The foot that made these tracks was planted, the entire sole pressing flat against the ground with each step from heel to toe. This is how you walk right now. It is not how any other living primate walks. It is not how bears walk. Plantigrade bipedalism in the living world is essentially a human signature, but the analysis went deeper than gait. The Trekilos prints show 5 toes arranged in the progressive pattern where they decrease in size from the big toe, outward, exactly as in human feet. They show no claw impressions whatsoever. Every animal that has claws leaves claw marks in soft sediment. The absence of claws here is categorical and diagnostic. And then there's the detail that stopped every anatomist who examined the data in their tracks. The ball of the foot, a distinct rounded impression just behind the big toe, pressed clearly into the ancient coastal mud, preserved in fossilized stone for 7 million years. The ball of the foot is not a feature that exists in ape feet. It is a specific anatomical structure, a pad of fibrous tissue and fat positioned to absorb the impact of each stride and to serve as the lever point for bipedal push-off that evolved specifically for upright walking. It does not appear in convergent evolution casually. 1 million years before the famous Litoli footprints in Tanzania that had previously been called the oldest hominin tracks on Earth. The dating of these prints is as geologically solid as any fossil evidence in the record. The tracks occur in a rock layer sitting directly below the sedimentary horizon, deposited during the Messinian salinity crisis, a layer that has been globally dated to approximately 6 million years ago. The footprints predate that layer. They were made before the last retreat of the Mediterranean Sea. This gives an immediate hard upper boundary on their age. They cannot be younger than 6 million years, because the rock layer that sits above them is exactly that old. Foraminifera, microscopic marine organisms, whose shells are preserved in the surrounding sediment and whose species compositions change in documented patterns over geological time, were sampled from layers above and below the track-bearing horizon and further constrained the age estimate. The original 2017 publication placed the prints at approximately 7 million years old. A 2021 reanalysis by a team at the University of Tübingen using magnetostratigraphy and cyclostratigraphic data pushed the estimate back further to approximately 6.05 million years. That additional 350,000 years may sound like a small adjustment. Consider that our own species, Homo sapiens, has only existed for approximately 300,000 years. The revision pushed the Trachylos footprints back by more than the entire lifespan of modern humanity. Now, the question that every person who hears this story immediately asks is the obvious one. How is this possible? How does a creature with a human-like foot end up walking along the coast of what is now a Greek island 6 million years ago, when the standard textbook story says that the earliest hominins were confined to sub-Saharan Africa until less than 2 million years ago? The answer lies in a world that looked almost nothing like the world we know. 6 million years ago, Crete was not an island. The Eastern Mediterranean had not yet completed the tectonic separation that would eventually produce the islands of Greece. What is now Crete was connected to the Greek mainland, which was connected to the broader Balkan Peninsula, which was part of a continuous landmass stretching across southeastern Europe and connecting southward to North Africa along the eastern Mediterranean coastal corridor. A creature living in what is now Crete 6 million years ago was not marooned on an island. It was living on a connected landmass with a direct land route that ran without significant geographic barrier all the way to East Africa. And here is the second piece of the geographic puzzle that makes the Trachylos discovery not just possible, but coherent. The Sahara Desert did not exist 6 million years ago. The vast hyper-arid expanse of northern Africa that today forms one of the most effective biological barriers on Earth was, in the late Miocene, a mosaic of savanna, open woodland, and grassland that was continuous, with the East African savannas, where the oldest African hominin fossils are concentrated. There was no Saharan barrier between East Africa and the Mediterranean coast. The landscape that ran from Kenya northward to what is now Greece was ecologically open and accessible to any large savanna-adapted primate capable of following the grassland corridor. Per Alberg stated this plainly when the paper was published. He said, "It is not difficult to see how early hominins could have ranged across southeastern Europe as well as Africa and left their footprints on a Mediterranean shore that would one day become part of the island of Crete. A creature adapted to open savanna environments in Africa could walk from East Africa to the coast of what is now Greece without ever leaving its ecological comfort zone, because in the late Miocene, that route was one long, continuous savanna." The scientific establishment's response to the Trachylos footprints has been, as might be expected, sharply divided. The most common objection from skeptical researchers is not about the dating. The geological constraints are difficult to challenge, and not about the bipedal character of the prints, which the morphometric data supports strongly. The most common objection is about the identity of the trackmaker. Could an unknown Miocene primate, not actually a hominin, but something that independently evolved a human-like foot through convergent evolution, have made these tracks? It is a legitimate scientific question. Convergent evolution is real. Dolphins and fish evolved similar body shapes through separate evolutionary paths. Birds and bats evolved wings independently. Could a non-hominin primate living in the late Miocene Mediterranean independently evolve a ball of the foot, a non-divergent big toe, a plantigrade gait, in the absence of claws all at once? The researchers acknowledged this possibility directly in their paper, which is a mark of genuine scientific honesty, but they also pointed out why convergent evolution struggles as an explanation here. The human foot is not a single feature. It is a system, a coordinated cluster of anatomical structures that work together to enable efficient bipedal locomotion. For a non-hominin primate to independently evolve every element of this system in precise combination would require convergence of specificity that has no parallel in the primate record. And that strains the principle of parsimony, the scientific principle that the simplest explanation consistent with the evidence is usually the right one. The simplest explanation for footprints bearing every defining characteristic of a hominin foot is that they were made by a hominin. And here is where the story connects to another discovery that was already quietly unraveling the Africa-only origin model before Trachelos arrived to push the debate into an entirely new dimension. In May 2017, just 4 months before the Trachelos paper was published, a team led by Professor Madeleine Böhme at the Senckenberg Center for Human Evolution published 2 papers in the journal PLOS ONE, reanalyzing 2 fossils that had been known for decades but never properly understood. The first was a lower jawbone, found during World War II near Athens, Greece in 1944. Found during a conflict so catastrophic that this extraordinary scientific specimen was essentially ignored at the time of its discovery and filed away without the attention it deserved. The second fossil was a single upper premolar tooth found in Bulgaria. Both belonged to a Miocene primate long classified as an extinct great ape under the name Greco-Pithecus freibergi. Scientists had assumed for decades that Greco-Pithecus was simply an ancient ape, interesting to specialists, irrelevant to the human story. What Böhme's team found when they applied modern CT scanning to these fossils demolished that assumption with clinical precision. The internal tooth root structure of Greco-Pithecus was unlike any known ape. Great apes have 2 or 3 separate diverging roots in their premolar teeth, a consistent and diagnostically reliable anatomical pattern. Greco-Pithecus had premolar roots that were partially fused, converging toward each other, a structure described as characteristic of members of the human lineage, including Ardipithecus, Auroran, and early Homo. The lower jaw showed additional features consistent with pre-human classification, and the dating of the geological sediment sequences at both the Greek and Bulgarian fossil sites produced a number that made the paleoanthropology world pause. 7, 2 million years ago, Greco-Pithecus freibergi, now nicknamed El Greco by the researchers, is 7, 2 million years old. That makes it hundreds of thousands of years older than Sahelanthropus chidensis from Chad, the 6 to 7 million year old African specimen that had been considered the oldest plausible hominin. If El Greco is genuinely a pre-human rather than an ape, then the oldest known member of the human lineage is not from Africa. It is from Greece, and it lived in the same late Miocene landscape where 1 million years later, something with a fully human-like foot was walking along the shore. The implications of placing these 2 discoveries side by side are considerable. A 7, 2 million year old possible pre-human from Athens. A 5, 7 to 6 million year old set of bipedal footprints with a ball of the foot and a non-divergent big toe from Crete. Both from the eastern Mediterranean, both from the same late Miocene geological window. Both from a landscape that was, at the time of their making, directly connected to East Africa by a continuous savanna corridor without geographical barriers. The standard model of human origins says none of this should be possible. The Miocene Mediterranean is not supposed to be in the human story this early. Hominins are not supposed to have been walking with modern style feet 1 million years before Ardipithecus, which itself had a more primitive, partly ape-like foot with some degree of big toe divergence. But here's the thing about Ardipithecus that makes the Trachelos paradox even more acute. Ardipithecus ramidus, the Ethiopian hominin dated to approximately 4 million years ago, had a foot that retained a divergent, grasping big toe, a partly ape-like foot that scientists read as evidence for a creature still spending significant time in trees. It is often cited as evidence for the gradual evolution of the fully human foot from a more ape-like predecessor. But the Trachelos prints, made 1.5 million years before Ardipithecus lived, show a foot that is already more human in configuration than Ardipithecus, a non-divergent big toe, ball of the foot, plantigrade commitment. If these prints are genuinely hominin, then the human foot did not evolve gradually and continuously from an ape-like Ardipithecus-style foot through the sequence the textbooks describe. Something with a more advanced foot exists before Ardipithecus in a different part of the world, walking along a Mediterranean beach, while the sea behind it prepared to die. That something left no bones at Trachelos, no skull, no jaw, no limb fragment, no teeth, nothing that would allow scientists to assign it a species name or place it precisely on the human family tree. The 50 footprints are everything, and 50 footprints, as extraordinary as they are, cannot tell you what the creature's face looked like, how large its brain was, whether it used tools, or whether it belongs on the direct line to Homo sapiens, or on a separate branch that eventually went extinct without contributing to the living human lineage. These are the questions that keep researchers who work on the Trachelos material awake at night, because the honest answer to all of them is that we do not know. El Greco, the 7 million year old Greco-Pithecus from Greece, is the most plausible candidate for the ancestor or close relative of the Trachelos trackmaker. Geographically and temporally, the fit is as good as anything in the Miocene fossil record. But Greco-Pithecus is known only from a jaw and a tooth. We have no idea what its feet look like. The connection between El Greco and the Trikailos prints is chronologically reasonable and geographically coherent, but it is inference, not proof. What the discovery has done, and this may be its most lasting contribution, regardless of how the specific debates about identity and phylogeny eventually resolve, is force the field of paleoanthropology to confront an assumption that it had held so long and so comfortably that it had stopped examining it. The assumption that Africa is the only place that matters in the story of human origins. For a century, the fossil record appeared to support this assumption because the fossil record of early hominins was overwhelmingly African. But fossil records are not neutral samples of ancient reality. They are products of where researchers have looked for how long, with what resources, and under what political and logistical conditions. East Africa has been intensively, systematically, extraordinarily well excavated for early hominin fossils for over 100 years. The Miocene fossil record of southeastern Europe has not. The Miocene fossil record of southeastern Europe is sparse, not because nothing was living there, but because the systematic scientific attention that built the African record has never been applied to the Mediterranean with equivalent intensity. The Trikailos footprints were literally walked past by tourists for years before a professional happened to notice them. How many other sites? How many other fossil surfaces? How many other preserved moments from the Miocene Mediterranean landscape are sitting unnoticed under the feet of hikers and beachgoers and farmers in Greece, Turkey, Bulgaria, and the islands of the Aegean? The Mediterranean itself, during the Messinian salinity crisis that brackets the Trikailos tracts, changed dramatically. The climate shifted. The corridors connecting Europe to Africa changed as the sea level dropped and new land connections formed and old ones were severed. And then approximately 33 million years ago, the Strait of Gibraltar reopened. What followed, the Zanclean flood, as geologists call it, may have been the largest single hydrological event in Earth's history. Atlantic water cascaded through the reopened strait, at rates estimated at 100 million cubic meters per second, roughly 1,000 times the discharge of the modern Amazon River, filling the empty Mediterranean basin with an inflow so massive that sea level may have risen by 10 meters per day in some phases. The Mediterranean refilled. The land bridges that had connected Europe to North Africa when the sea was low were submerged again. The Savannah corridor that had allowed free movement between the Balkans and East Africa was broken by the returning sea. And whatever creatures had been ranging across that connected landscape, including perhaps the bipedal primate that walked along the Trikailos shore just before the retreat, found themselves separated from populations on the other side of the water by a barrier that would eventually become, for some of them, permanent. The footprints in the rock at Trikailos were made in the last moments before all of this happened, just before the Messinian salinity crisis completed its final phase and the sea pulled back for the last time. The trackmaker walked along that beach at the edge of a geological catastrophe, pressing its human-like feet into the coastal mud without any awareness of what was about to transform the world around it. And then the sediment hardened. The sea retreated. The salt desert took over. And eventually, millions of years later, the Atlantic came back and buried everything under the returning sea. And millions of years after that, the tectonic forces that had been reshaping the Mediterranean landscape since before the Miocene ended finally separated Crete from the Greek mainland and pushed it up into an island. And the erosion of that island over millennia slowly uncovered the ancient coastal surface where those 50 prints had been, waiting in the rock, waiting for someone to kneel down in 2002 and look at them properly for the first time, waiting for the CT scanners and the laser imagers and the morphometric software and the foraminifera biostratigraphy and the cyclostratigraphic analysis that would eventually tell the world how old they were and what kind of foot had made them, waiting for science to catch up to what the rock already knew. What the rock knows is this. 7 million years ago, and possibly 6 million years ago, older than any previous estimate, older than any African fossil confidently claimed as a biped, something walked along the shore of the late Miocene Mediterranean. It walked upright. It walked efficiently, with the heel-to-toe weight transfer and the 4-foot push-off that defined the human gait. It walked on feet that had a ball behind the big toe, 5 forward-pointing toes without claws, and a non-divergent big toe pointing straight ahead in the direction of travel. It walked on feet that, placed side by side with the footprints of a modern human, are more similar than different. And then it walked into the geological record and disappeared, leaving behind no bones, no name, no story anyone can yet tell completely, leaving only footprints in ancient stone, leaving only the question that those footprints press into the foundations of everything we thought we knew about where we came from, and leaving, for anyone willing to follow them, a trail that leads not to a single origin point in a single African valley, but to a world far wider, far older and far stranger than the one the textbooks describe. The trail starts here, in Crete, 7 million years ago, on the shore of a dying sea, in the footprints of someone whose name we do not know and whose face we have never seen, walking into a future that would eventually, after unimaginable spans of time and change and extinction and survival and adaptation, produce the species. Sitting here reading these words, we do not know who they were. We do not know exactly where they came from or where they were going. We only know that they walked, and that the way they walked, pressed into the ancient rock of a Mediterranean island that did not yet know it was an island, looks disturbingly, beautifully, undeniably like us.